So this is Algebra 1, Semester 1. This is a unit called Functions. It's the 5th unit, and it's the 4th lesson called Multiplier Practice. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents, with the notes for those pages from creatormath.com. So the notes can be difficult for students to find. I tried to go through and model that for you here. And so I'm going to pull up the creatormath.weebly.com site on my phone, because that's the way most of my students do it. All right, not all, but it'll work on the internet too, or on your phone. So here's the actual name of the website, creatormath.weebly.com. Type that into Google. If you are able, I hope you get to this home page. Looks like this. All right, and that's how you know you're on the right site. Any questions on your composition book, which for students is difficult to understand. There's a lot of requirements for the composition book. I get it, you guys, but you got to go to this site, find the words composition book, and you got to read all the directions, watch all the videos, adhere to the turn-in dates, and put everything in the places where it belongs, right? It is a lot of work, but if you do it a little bit each week, one small step each day, and your notes for the course, because it's hard to take a course in math without some notes to back you up. So I'm going to go ahead and click here under the tab for this course for the video that I'm making right now, and you're going to click into the course, of course, that you're in. So under this tab, you'll find 5 things, at least, maybe some more things, but 5 things. You're going to find the notes. You're going to find the practice sets, which I'm going to do right now. You're going to find the video of the practice sets, which we're making right now. You're going to find the page numbers where everything goes. I'll show you that in a minute. Okay, and also you're going to find the PDF of all the vocabulary we use throughout the school year. It is downloadable to your device, and it is searchable. Just Google, how do I search a PDF with whatever type of device you're on, and you should, if you're not already, you should be getting 100% on your vocabulary practices. That's the point, you guys. It's to help you engage in the vocabulary and to engage in the words that we'll be using throughout the semester. All right, so now I'm going to go to the proper semester for the video I'm making. All right, under the semester will be the table of contents for that semester. It's so important, I ask you to copy the entire thing into pages 2 through 6 of your composition book. If you haven't done that already, please stop what you're doing now and watch the videos back on the home page of how to number your pages on your comp book and how to write in the table of contents. It's pretty long. It's about 3.5 pages long. Why is it so important? Why do I ask you to do all that work? Because the page numbers allow you to now know what goes on every page in the comp book, to put the right things on those pages. That way, when I check 200 comp books, right, I can at least find what's in your comp book, and I can give you credit for that, and I can give you that great grade on that composition book. And of course, the notes you have in there are for the purpose of backing you up in the problem sets that we do and the discussions, etc., right? You need a basis for that, a foundation. So now I'm going to go to the unit that we're in for this video. This is the functions unit. There are 7 lessons within this unit. We are looking at the 4th lesson here, so we're going to go right down to number 4. It says multiplier, and here are the page numbers on which the notes go. Please don't take this video's word for it. By the time you watch this video, these page numbers probably will be different, so please just go to the original table of contents at the time you're viewing this and find the real page numbers, but here they are to show you where they are. Here are the notes that we're going to look at briefly. Here's the problem set we're going to go over, and this video will be linked here to video solutions if everything goes well. So we're going to click notes. Fair warning, it takes me twice to open some of these sometimes. All right, so, and this one is not opening. Yeah, it did. It took a second there, but it opened. You should be able to expand on it and then examine and go ahead and copy these notes into your composition book. So we've been through, this is the 5th unit, right? And this is the 4th lesson within that. So we've been through a bunch of different concepts. So this is talking about rate. A multiplier is a rate. So f of x equals 3x plus 1. This should all look familiar to you as we've been using function notation for quite some time in this semester. So the multiplier is the slope in this case, or the rate in this case. What is it? It's 3. So what's happening? We're multiplying this multiplier by these values on the x-axis here. This is the x-axis, the y, and that allows us to define, in this case, a rate. So the multiplier sets the rate of an increase in this case. So the multiplier is positive because it's a positive 3, so the rate increase is positive. And we know that by now, hopefully, any graph that goes up to the right like this is a positive rate. Any graph that went down to the right like this would be a negative rate. All right, so we talk about slope. Now we switch into another concept that you should know by now. Slope is rise over run. Here's rise 3 over run 1. We rose 1, 2, 3. We ran 1, and that defines the next point from the y-intercept, which was 1. So we started at y-intercept 1. We rose 3 over 1, 1, 2, 3 over 1, put another point, rose 1, 2, 3 over 1, put another point, and this defines a rate in this case, or a linear graph in this case, a graph of a line, which then describes certain physical phenomenon potentially. All right, so this is a steady change. It produces a line. The graph is a line or linear because the change is steady, right? And actually there can be changing rates where it can be accelerating or decelerating. Just like in a car, you're never going one set speed in a car. Say the speedometer says 35 miles an hour. For that instant, you're going 35. But in general, the car is then slowing down, where the speed is dropping through 35, or increasing, going up through 35, right? Very rarely are we able to keep that car at exactly 35 miles an hour. It's virtually impossible. Just think of it, you know, and you don't drive yet, or maybe some of you are, but you put a little bit of pressure on the gas, you speed up a little bit off, and you slow down, and that car is constantly going through the 35 speed, but sometimes increasing, sometimes slowing down, right? Anyway, we'll talk about that more as time goes by. So multiplier is the slope or rate in this case. A slope is a rise over run. A rate is the increase or decrease. The steady change is a constant change or a constant rate. All right? So those notes will help orient us to what we're going to see in this lesson. Let's see here. Given the following geometric sequence, a times r caret n minus 1, what is a? So this does sort of go back a little bit to prior lessons. This is the 4th lesson. This is reaching back a little bit. So what is a? They're asking about this format, right? And we've had different formats. We've had a times b to the x. We've seen those. This one is an a times r to the caret n minus 1. N is the term number. R is the rate in this case, we're going to call it, and A is the initial term. All right, so what is A? A is the initial term. All right, so we've seen even in past lessons where, say, we were loaning money and it was $600, A would be $600, the starting place, or the y-intercept. All right, so given the following geometric sequence, now they're going to go through what is N. N is the term number. So how many terms does it have? If you're here, 1, 5, 9, each one of these are terms. This would be term 1, sometimes called 0, and this would be term 2 and 3, right? Sometimes reversed out if this becomes term 0. And oftentimes if you have an n minus 1, you can have a term 0. All right, so let's go to the next one. Given the following, the same thing, what is r? R is the multiplier. Okay, so we just learned that the multiplier was the rate of change, or R. That's why an R is used for rate of change, or multiplier, or rate in this case. All right, so we're using different words to mean the same thing. That's the rate of change, and we're talking about, is it accelerating? In this case, we're talking about constant rate of change, which we've mentioned in the notes, and now a couple of times throughout the lesson. So given the following geometric sequence, 5, 10, 20, 40, 80, right? What's happening here? This is going up by 5. This is going up by 10. This is going up by 20. What's happening, right? It looks like this is being multiplied by 2. So what we did was times 2 to go from 5 to 10. What we did was go times 2 to go from 10 to 20. Each of these terms being multiplied by 2. Okay, and the format of a geometric sequence is this a times r to the n minus 1. There needs to be a caret in there. Okay, let's make sure that's done. I'll make sure that's changed by the time you see this. And I see it on the following pages too. I'll fix that typo for you guys. So given the following geometric sequence, what's happening here? So the starting point is 5. So here we have a starting point of 5. Notice that. The rate is 2 because we're multiplying by 2 along the way. And do they ask us about a term? Given the following geometric sequence of this and the format this, what would be the value of the third term? So now we're going to go third term is 3 minus 1, or 3 minus 1 is 2, or 20 in this case, okay? And how do we get that? We put that into our calculator. Nope, let's go here, here, and here, and let's turn our calculator sideways so we can raise it to the power. Let's see if I can get all this to where it can be seen. All right, so here we have 5 times 2 to the caret 2, right? 5 times 2 raised to the power 2, and let's close it with a parentheses right here. So 20, that's our 20 right here, right? So you should use your calculator, practice raising things to the power, practice these on your calculator. You're living in a tech world. You need to be familiar with tech if at all possible, and if anything, you're more advanced than me. So I'm trying to catch up with you on that note, all right? So given the following geometric sequence, here we are again for the following format, what would be the value of the fourth term? So now we have the same thing. We've got this a times r to the caret n minus 1. Make sure we got that caret in there, all right? So a is the starting point, 5. R is the value we said we are being multiplied by 2 each time. And this is to the power n minus 1. We want the fourth term, so 4 minus 1. So here we have 5 times 2, caret 4 minus 1, or 5 times 2, caret 3. And just modify our calculation to see if we get 40. All right, 5 times 2 to the 3 power. Let's back this out, and there we are at 40. Check. All right, so let's see what we got next. And this is practice on geometric sequences. It's a continuation from the prior lesson, so even when I look at the notes, they're a little bit vague on this, but nonetheless continuing the prior learning material. Given the following sequence, so 721, this is interesting. It looks like we're multiplying by 3 here. Is 3 times 21 63? Sure enough it is. So look, our r in this thing, the r is 3. The starting point is 7. And the power we're raising this to is n minus, where we want a third term, is 3 minus 1, or 2. So this equals 7 times 3 to the power 2. Put a times in there where it can be seen. Caret 2. So here we are here. Is it 63? Let's check. 7 times 3 to the power 2. Let's make this 7. And it might be easier just to retype the whole thing, since I'm changing every number here, but that's all right. It's kind of fun to change the old 63. Sure enough, that matches up here. It looks like they may take us through the same thing and now say the fourth term. So it's 7 times 3 to the 4 minus 1, which equals 7 times 3 to the 3 power. Is that, in fact, 7 times 3 to the 3 power? We're just changing the power here. 189. Check. All right, so some additional work on geometric sequences and the idea of the multiplier being this value which becomes a rate in the whole situation, right? So make sure you're matching up the title of the video with the problem set you're doing, otherwise it's not going to make much sense. This is Algebra 1, Semester 1. It's the 5th unit called Functions and the 4th lesson called Multiplier Practice. It's on creatormath.com under the Algebra 1 tab. Hope that helps.